Hi and welcome. Today's video is a very introductory one about Spring Boot. It's a getting started with Spring Boot. For that, we're going to create a simple task manager API, which allows us to list tasks, create tasks, update tasks, and delete tasks. The CRUD operation, right? So for that, we are going to use obviously Spring Boot. We are going to create the application using a Spring initializer, and then we are going to use Spring Web Starter to make the REST layer of application, Spring Data JPA to make the access to the database using ORM, and also the H2 database, which is an in-memory one. So you don't need to take care about containers, Docker, and so on. And this is a database that it is initialized once the application gets started and destroyed after the application shuts down. So let's get started. So the first thing we need to do is access the Spring Initializer site, which is start.spring.io. For that, we are going to use Maven as the package manager, Java's language, Spring Boot version. The important thing here is to be 3 point something, okay? The emergent version needs to be 3. Here, a little recap about Maven. I don't know if you, in specific, is getting started with Java in general or just Spring Boot, but just in case, Maven is a package manager for Java, also Gradle. We are going to use Maven for a while, but doesn't matter. On a Maven or Gradle project, we need to define a group ID, which normally is the domain of your company or your domain, but in the reverse. So instead of igventurelli.io, it is io.igventurelli. The artifact is the application name or the module name, and the name here is something that doesn't need to be like this. You can have space and capital and so on. Description, whatever. The package name, it normally works that way. Just your group ID dot artifact ID and the following package. So you normally don't change that. Packaging jar. This is different from the Spring regular Spring not boot application, which was war packaging, right? Which stands for web archive. But for Spring Boot, we're going to use jar, which is Java archive. Okay, both are zips file. But yeah, that's it. We're going to use jar. For Java version, let's keep 17. It doesn't matter for now. For the dependencies, you can hit that button and type whatever you want. So in our case, Spring Web, which I already selected, which allows us to define RESTful applications, Spring Data JPA, which allows us to use the JPA and with Hibernate to access databases using ORM, right? And also the H2 database, which is an in-memory database, okay, which is very small, 2 megabytes footprint. And that's it. Just hit the generate button and open on your IDE. Cool. I just generated, extracted the zip, and open on my IntelliJ. Once again, let's make a really quick recap about Maven. I don't know if you are familiar with Maven or not. In case you're not, let's see that. So by a Maven application, there are one file and one directory that is very important. The file is the pom.xml. This guy here defines some properties regarding the build of your application and also the dependencies of your application. If you are familiar with Node.js, this is the same thing as package.json, okay? We have this MVNW thing here, which are binaries of Maven. In case it is useful for containers, right? Like you don't have Maven installed, so you can embed Maven to that. So this is pretty useful, by the way. So you just need to run that in order to run your application. right? MD doesn't matter, git ignore, git attributes, blah, blah, blah. This folder here is just the IDE, doesn't belong to the application actually. This is something related to Maven as well. You don't need to take care of it. The important directory here is the src, which contains your source code, right? So it's basically split it into main ones. Like the main is the productive code, and the test is for testing code. We have the Java folder, right, which will contain Java files. And here, this thing here is a package, right? It is similar to folders. And actually, if you go to your file explorer and go to the application, you see files. So sorry, folders. Like IO is a folder. Under that folder, you have IG Venturelli. Under that folder, you have the task manager folder. And then you have this class here. This class is the main class of the application. Again, if you are already familiar with Java, this is a regular main application, main class. If you're not familiar, this is where your application runs. Okay, when you write a simple Java code, this kind of thing doesn't belong to Spring Boot. This is regular Java code, right? This public static void main, an array of args, array of strings. This is a regular Java code, doesn't belong to Spring Boot, but Spring Boot uses that, okay? And this class, you can see that has an annotation called Spring Boot application. Let's take a look on it. Let's see the docs. Indicates a configuration class that declares one or more @bin methods and also triggers auto configuration and component scanning. This is a convenience annotation that is equivalent to declaring Spring Boot configuration, enable auto configuration, and component scan. Right? So basically, this is a kind of collection of annotations of these three annotations. Okay, it's just an alias for that. And there are some very interesting things here, like bin. Okay, bin on the context of Spring is some like method or instance that can be handled by Spring. So by defining a bin, you can inject that piece of code, whatever you want on your application, and the lifecycle of that bin is managed by Spring. Auto configuration is something that comes with Spring Boot, not Spring. There are different things, okay? Let's take a look on this very useful blog here. We have a simple matrix, a feature matrix comparing Spring, the regular Spring framework, and Spring Boot, okay? So again, this bin thing here, this bin concept is part of the Spring framework, which has been inherited by Spring Boot, okay? So by Spring Boot, we have this thing called auto configuration. What does it mean? You can think like for database connection, right? Normally, any company in the world needs to define some properties like URL, username, password, and maybe the driver class the most, right? This is pretty common. So you don't have to write code like that. And you even importing some library, you would need to integrate that library. This is the beauty of auto configuration. You don't need to do that at all. In our case, we already imported the Spring Data JPA dependency, which expects us just to provide the URL, username, and password. So all the boilerplate related to that, and all the integration related to that is already handled, is already configured. So you don't need to configure that on your own. Okay, so that's basically what auto configuration means in a very, very simple manner. Okay, component scanning. So do you remember about bin? So in order to make the bins available, Spring needs to look at that somehow, right? To search for that. So this is what component scanning is again, in a very simple way to say. This is where how Spring detects that beans you created. So you need to define like, hey Spring, look at from this directory and so on, So the component scanning, the default one, starts here. So everything that you create under this task manager package, it will be scanned by Spring Boot. So yeah, cool. So this is a really quick introduction about Spring Boot. One other very important file of Spring Boot is under the resources folder. Resources is the place where you put any other file like JSON files, XML files, whatever, image, whatever you want that is not Java file. Okay, so we have the application.properties file, which can also be, if you prefer, like application.yaml. It's pretty much the same idea and the same structure of the properties we can define. Just the only change is how to define, right? Like the application properties, we can define like Spring, data source, URL, JBC, localhost 5432, like for example, Postgres database like MyDB. Okay, so the same thing it would be under the application. Oh, my bad, I did on the wrong one. It's supposed to be here. Okay, it already has this kind of thing, but it's not relevant. This is just an example. Okay, so here it would be like this. Okay, pretty much the same idea. Let's keep the properties for instance. And okay, so the first thing we need to do, we're going to create a task manager application, right? Is to define what a task is, right? For that, we're going to define a class, which is the domain, is the model of your task. So for that, let's create a package. And we normally split the code in packages, right? Like called model, sorry. And then let's create a class. To open this pop-up here, just type control, I think it's control, in case of Mac is command N, and then you have that. Let's call it just task. Let's make it an entity. Entity. Please pay attention to the import like jakarta.persistence. So by simply annotating with this annotation, so your Spring Data JPA is going to identify that as a structure that needs to be mapped to a table under the database. Okay, so this is basically a table on your database. Okay, again, this is a very simple explanation. It's a very introductory level stuff. And let's define some attributes. So here we have ID, title, description, and a boolean for completed, right? So again, it's a task. So as a task, it will have an ID, a title, description, and a tag flag to identify it is completed. For the ID, we have a special notation also from Jakarta persistence, which is ID, which identifies the primary key of your table. Again, this is a table definition, right? And also, this ID needs to be auto incremented. So for that, we're going to use generated value. Let's set this strategy as generation type identity. Let's take a look on these docs here. Defines the type of primary key generation strategies for identity, indicates that the persistence provider must assign primary keys for the entity using a database identity column. So this is basically, oh, please generate some ID for me. Okay. For the other ones, let's keep the way. You can, if you want, like you can have the column annotation. if you want the name of the column different from your attribute, like let's say I want to have the name whatever, but my bad, I think this is like name. Okay, in our case we're going to use the default one, so it doesn't matter for a while. Okay, by this we already have our model and table defined, right? So what we have to do now is to define the repository. Repository is a layer of our application which uses the entity to communicate with the database. Like entity is just the definition, right? But the actions doesn't belong to the entity. We need repositories to do that, like save, like update, like select, like search for, right? So for that, let's go and create another package called repository and create an interface that's important called task repository and extends from JPA repository, which has two generics. Whenever you see this kind of diamond stuff, repository, can you see this less than, more than, greater than, sorry, T and ID. I will explain that in a second. So let's set task and long. Okay, what the hell? I know this is pretty confusing. Let's start from the end and then get back. So here, the JPA repository is a repository already defined by Spring Boot, by Spring Data JPA, sorry. So you don't need to write that kind of boilerplate code to persist a data on our database, as we already have the definition of the table, right? You don't have to write the boilerplate code to select something from the database, from that specific table, because we already have the definition. So you don't need to do that, you know? So the type here, this is generics, okay? Generics means that you can type things, okay? I think TypeScript already has generics. I don't know, I really don't know. I think so, right? So it's pretty much the same idea. And here, long is the type of the primary key of your type, right? In our case, this long here. And again, this is the interface. An interface in Java, despite of default methods, it cannot have code. It's just definitions, right? The signature of the methods. So again, by extending JPA repository, it will inherit it will gain a lot of boilerplate code already made, so you don't need to take care of it, and you only need to write anything here, like if you want to have something like list of task find by title, string title. And also, this is the beauty of Spring Data. As you have the title wrote exactly the same way, like your property, Spring Data JPA can identify like, this is a find by operation. Okay, so this is select from blah 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 from task where title equals this one. So you don't need to even write this code. Okay, just the definition, and Spring Data JPA will handle the rest for you. Okay, really cool. So now the last thing to do is to define a controller. And for that controller, I will create a package. One thing important here, for package, the convention is always in lowercase, and for Java class, the first letter needs to be capital 1. Okay? Controller is the layer of our application which handles HTTP requests. So let's create a class task controller. For that, we need two annotations here. The first one is REST controller. Let's take a look on it. Okay, this is really big. I won't read that. you can trust me. This is basically telling Spring, oh, this class is a controller, and you're going to map any HTTP request you're receiving under this class, okay? And in case you have like a custom path like slash task, for example, you can define like request mapping and slash tasks, okay? Let's make it actually API tasks. So in our case, it would be localhost 88 slash API slash tasks, and everything from there will be mapped to this class. Really cool. So let's start with a very important concept of Spring. And again, this is part of the Spring framework, not Spring Boot, but it's the, I think, the backbone of the Spring, because actually the Spring framework is a dependency injection container. So if you don't know about dependency injection, Google it or ChatGPT it. But it's basically, you don't need to create instances of classes on your own because you are going to inject beans. Do you remember the add bean on the beginning of the video? So when you define beans, you can inject them. And to what do we need to do? We need to access the database, right? Let's say we received a request to list all of the tests we have. So, okay, let's first create the method to receive that. So for that, we can define a get mapping. By tagging a method with this, it says to Spring like, oh, for any get request you receive under this path maps to this method, okay? So it needs to be public. The type of return is response entity of something. Actually, we can tag it as task actually from list of task, okay? Response entity is a wrapper on the Spring Web, which allows us to define some useful stuff about how we can respond HTTP requests, like status code, body, headers, and so on. You could, if you want, like make the response like this directly, because Spring is intelligent enough to make that as response and understand that this is the payload of the response and then respond the list of tasks. But it's a good thing to do is to wrap your responses under a response entity, okay? So let's take find all. The method name, it doesn't matter for the HTTP request, it's just the Java code, okay? So the URL doesn't need to be slash find all at all. It will be just this, okay? You can name whatever you want, okay? We keep this kind of pattern just for convenience. For that, we need to return a response entity of something, right? Like, where is the list? Where is the list of tasks? So first, we need to access that repository in order to ask the find all, right? How we can do that? So this is again the beauty of Spring Framework. This is dependency injection. For that, we can use auto-wired, which I do we will refactor in a second. And then we can define like task repository, and that's gonna work. Let's say return repository dot. Can you see all these methods? We didn't find that, right? The repository is empty. This is inherited by the JPA interface. So that's it. We cannot return that directly because we are expecting a response entity, right? Response entity dot OK, which means it will return HP 200 with this body. Let's see if that works, but first we need to set up our connection to the database. Remember that this is pretty wrong. Let's fix that. Now we have some useful attributes here. So can you see spring dot something, spring dot dataset, spring dot jpa, spring dot h2? This means like these attributes are Spring defined. You can define on our own, like Igor dot name, like Igor. You can do that. These ones are used by Spring, and this Spring data source stuff, and actually, and all these are from Spring Data API. And this is the URL of the database, driver class name, username, password, which is empty, and dialect. This is a configuration from Hibernate to update the database whenever the application started. But in our case, the application is always created in the database, so it doesn't matter actually. And here, this is just a console. If you want to access and see the data on our database, you can go to the console here. Super cool. By doing that, we should be ready to run our application. Let's see. Looks good. Let's take a look. Yeah, it says database info. Okay, connected. Okay. You can go the console. Do you remember that attribute about console? You can go to your browser and type localhost 88/h2 console, and you can connect to the database if you want. Okay. Okay, super cool. Let's try with Postman. I already have a collection here that I created for this example. So yeah, HP localhost 88 API tasks. Let's see. Okay, it responded an empty array because we don't have anything on our database, but 200. So it is working. To prove that, I will add something like yeah. Let's rerun the application. And see again. And you can see it prints yay. So that's working. So one thing you need to do, as I said, I wouldn't suggest to use outright here because this breaks the private thing, right? In theory, when you define a privacy, attribute or method, external classes couldn't access that. By annotating with outright, you are forcing Spring to break this rule and inject anyways it here. And to avoid that, we can remove that, make this as final, and then it's going to say, oh, okay, I need to be initialized, right? Because this final modifier is like, oh, this cannot be override, right? So for that, we need to define a constructor. Task controller, which receives a task repository, and then everything works. By doing that, you are following the regular flow, right? Like classes are constructed by using constructors. So when Spring tries to initialize this class, it will say, oh, the only constructor I have is expecting this task repository, and a repository is a bin. So I can, Spring will have that on the runtime, and then it will send to us here and make it available. So let's try once again. And yeah, that's working. And to make the video fast, now we have some boilerplate code to make the post, put, and delete routes. I will paste that here and explain right after, okay? Before that, something I totally forgot, is to define getters and setters. To do that, Control or Command N, getter and setter, select all them, and then you are good to go. And here we are. So just to illustrate that we can directly respond with the type you want instead of response entity. For that, I will return the created task here. Okay. So before trying, let's keep the code here. Now we have a put method, put mapping, which expects an ID, right? The put operation under the REST is something to update the record, right? The entity by a given ID. So you can see the curly braces here. It means a variable under the path. So you can see path variable, long ID, this matches to this. You can see the IntelliJ already highlight that. Request body is the actual body of the payload, and you can see it expects a task. So Spring can auto parse from the JSON to your domain class, to your entity class, right? So it expects like JSON with title, description, and complete. By the put mapping, we are going to make a find by ID on the repository. Again, I didn't define that. This is from CRUD repository. This is a super interface from our repository. And then we are going to set the content we are receiving here. And then we're going to save that. And then we're going to respond with no content, right? For put tabs under the REST concept, the response has no payload, just the status code 204. And also the delete mapping, which also expects an ID, and then just find that and delete. So let's try and make it run. Okay, so let me create a task. So write blog post as title, description, create a Spring Boot tutorial, and not complete. And you can see this is a Boolean, right? No, not a string. And ta-da! And can you see this is the post mapping, right? And I return it directly to the task, and it returned it. But this is the bad thing by returning directly the entity. Like this is a post, and the record has been created under the database. By the REST concept, when you create something, you should return 201 created and not 200, right? So let's fix that. So here we are going to save that and then respond to we've created and the content. Let's try it once again. Again, whenever we shut down the application, the database has gone. So if we try that once again, the ID will still be the one, right? And now it's 201 created. So let's list. And now we can have the list. Let's try to update that. Update the ID number 1 to an updated type, updated description, and complete as true. No content. Let's see if that works. It works smoothly. And now let's delete that, the ID number 1. No content. Let's see. Okay, that's working. So in this video, we saw how to create a Spring Boot application from the scratch using Spring Initializer. By that, we were able to see how the Spring Boot application works with the main class, the one annotated with the @Spring Boot application annotation, how to define some properties under the application.properties file, which is also part of the core of the Spring Boot, and also by adding the dependency of the Spring Data JPA, we were able to define an entity and also a repository to make the access to the database, write and read operations. And finally, we saw how to define a controller, exposing some get routes, some post routes, put routes, delete routes, right? By that controller, we were able to achieve the 4 operations of a CRUD operation, right? Create, read, update, and delete. So yeah, that's all for today's video. I hope you enjoyed it as much as I did. Stay tuned to the channel, hit the like button, subscribe to the channel, and see you on the next video. Bye bye.